Okay, class, we're on number 8. It says the graph of every inverse variation is a curve. The shape and position of the curve are determined by the constant of variation. Okay, so what is the constant of variation? Well, that's the letter A. Okay, we know that when we write our wonderful y, oops, need to get the white marker and make sure it's thick enough. Okay, yeah, it is. Okay. So y is equal to a over x, and a is the constant, okay, of variation. So we're told right now that the shape and the position of the curve is determined by that. So we're going to take a look at three different uh, functions, inverse functions, and we're going to see that the a value, or that constant of variation, is going to change. So we have y is equal to, well, let me give myself some room here. See, y is equal to 4 divided by x, right? We're also given y is equal to 6 divided by x. And then we're given y is equal to 10 divided by x. Now, I know we've done this before in our other lessons, trying to determine how that a value affects the graph. And now we're looking at the same thing here when it comes to inverse variation. So let's put an x and a y table for each of these. And let's just take a quick look here at what our values for x. We're told that x is going to be equal to 0, 1, 2. Aha, no, it can never equal to 0, so it didn't say that. All right, it's equal to 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So we need to do that for each of these and plug in the values. And this type of exercise is nice because it lays out in a visual sense how that a value is affecting and how the change of the a value affects the graph. And you're going to see it just in the table alone. So what happens when we take the first, y is equal to 4 divided by x? Well, let's see, 4 divided by 1 is 4. 4 divided by 2 is 2. 4 divided by 3 is 1 point, what is that? 3, 3, right? 3, 3. Okay. And then we have 4 divided by 4 is equal to 1, right? And then we could have just put 1.3 here too. Probably shouldn't do that because you say, well, how many? Let's just use one decimal. So 4 divided by 1. And again, we approximate. I don't know if you've already learned how to round, but this would be rounded down to 1.3. We'll go over that in some other chapters. And we have 5 divided by 4, and that would also be a decimal of 0.8. Okay? Now notice I put 0 in. We should put the 0.8. Let's go on to our next one. Well, 6 divided by 1 is going to be 6. 6 divided by 2 is 3. 6 divided by 3 is, guess what, 2. See the relationship. What about 6 divided by 4? That will be 1.5. And then 6 divided by 5 gives us another decimal, 1.2. Now let's go to 10. 10 divided by 1 is 10. 10 divided by 2 is 5. 10 divided by 3 is 3.3. And 10 divided by 4 is 2.5. Now you can do this math. You can either do it by hand. I don't necessarily mind calculators if you know how to handle the calculator. What I really want you to learn here is what's going on with this function over here and what's going on with the graph. I'm not interested in teaching you how to multiply and divide. Okay, that's something that you should have already learned. And if you have any challenges with it, well, the calculators help so you can focus on what you're learning here, and it's particularly with this graph. Okay, so what's going to happen? We see the numbers here changing. Notice that when this number a is small, okay, this number tends to be small. As this number goes up, so does this number. And remember, these are all the same, 1, 2, 3, 4, 5. So how is it affecting our table alone? Just make some observations. Notice this number is getting bigger, obviously, because this number is bigger. It's divided by 1. But, so we notice that our y as this a increases, our y numbers are higher, okay? So, well, what does that mean? Well, let's see what it looks like when we go to, let's see, D, we're to graph all three functions on one pair of axes. One pair of axes, we've already said, is basically just like one graph. Don't want three different graphs. Oop, I need to get a black marker. If we did three different graphs, we wouldn't be able to compare them unless you like laid them one on top of the other and maybe held it up to the light or something. So we don't have to do that. We can just put them all on the same graph, right? And we can compare them. And they do that quite a bit in comparison. When we have graphs, they like to compare things. Let's say this year versus last year. So you'll see a graph, and it has two sets of numbers and points, and you'll see the way the graph behaves last year versus this year. And sometimes it's easier to see it that way than looking at numbers. And particularly right now, we're looking at a whole bunch of numbers that maybe don't make that much sense. We can spot the trend, but we don't really see what it looks like visually until we graph it. So why don't we go ahead and start graphing? And it says graph all three functions. So what's our first point? Let's go up here. I'm probably gonna need to use three different colors. Let's try that. Okay, here's a nice experiment for us. Let's try using three different colors this time, so that they're not together. So the first one we're going to use, this one's going to be the red one. And let's see, x is equal to 1, then y is equal to 4. Okay, well, before we do that, I think we should probably write in black our numbers here. So we're just going to put 1, 2, 3, 4. And I'm going to go all the way to the top because we do have quite a bit. We see the y value peaks at 10. That's the highest y value that I have. So let's go with 6, 7, 8, 9, and then 10. It's way up here. And then we'll go 1, 2, 3. We should put our 0 value here somewhere. 4, 5, 6, 7. And again, this is what you should be doing as well. I think I'm missing something here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it is working. Okay, so now that we have our values laid out, oh, I do see the problem. I know that there was a missing 10, and I do apologize here. So why don't we just remove that? And you could do this as well. I can see if the teacher is making that mistake, couldn't you? We started here with the 1. That's really a 0. So let's do this again. All right, so I know you're having a good chuckle on my behalf. And it's funny because I knew something was wrong. I know I don't get the 10 on all of these, so somewhere in the back of my mind I knew that a number was wrong. And when you make mistakes, it's good to have done things in pencil. That's why we tell you, do things in pencil. Imagine you have a wonderful page full of many graphs, and you did them all in pen, and then you mess one up, and now you got to write all over it or scribble it out. It just looks ugly, doesn't it? With an eraser, you can just erase it like it never happened. See, mine never happened, though we did capture it on video. So let's go ahead and use our red color. Our red color we're going to use for this one, and we're going to say x is equal to 1, y is equal to 4. So let's plot our point here. Okay, that's our first point. Then x is equal to 2, y is equal to 2. X is equal to 3, y is equal to 1.3. Okay, so that's right around there. And x is equal to 4, y is equal to 1. All right. I wish I could draw better dots with this. Now, when x is equal to 5, y is equal to 0.8. So that's somewhere underneath the 1 not quite obviously halfway. It's really more than 3/4 of the way. So that should be somewhere around there. So we've plotted our points, and why don't we just try to draw this? Okay, I'm going to be challenged 3 times now. So you're really going to have a lot of fun at my expense in this video, watching me draw these. Okay, so that wasn't too bad. Hey, practice is making me better. Okay, that wasn't quite well connected, but I can see a curve. Now, let's do our next one. Let's get another color. I could go ahead and do green, though when I write the green, oh, okay, it's a lighter green. We're going to do that one. So we have 1 and we have 6. Okay, so now we already see a difference here. Then we have 2 and we have 3. So here we go. And again, I'm just following the table. We have 3, then we have 2. Alright, and then we have 4, we have 1.5, so that's going to be somewhere in the middle, between 1 and 2, directly in the middle. And then 5 is 1.2, which is, okay, this is 0.8, this is 1, but 0.2 is, it's the same distance from the line kind of going up. This is 0.2 less, this is 0.2 more from the 1. So we already have now our next line, and let's see how well I can connect these with a nice little curve. It's so much easier on paper. Alright, now there we go. I have a fond appreciation for those who can draw on these things. I just really messed that up, so let's just undo. What's really nice about these things, you can undo something and not totally undo it. So here we have now our second. Now let's go to our third, and we're going to use blue. So blue will be this one. So we have value of 1, 10. Let's go all the way up to 10. Now 10 we don't even have. It's off the chart. But we know it's going to be way up there somewhere. It's just almost the same distance. So that'll be 10. So we have 2, and that would be 5. Now you see these are not connecting in any way to the others. Of course, because the values are different. If this value A is different, then it's always going to affect all these values. It should never really be the same. So let's go. We had 2, 5. We have 3, 3.3. So here's 3.3 is about right there, 1/3 of the way up, let's just say. And we have 4 and 2.5. Okay, so there's 4, 2.5. And then lastly, well, we have 5 and 2. So that's an easy one. Don't have to go fishing for that decimal. So again, another curve we have to draw. This one's going to be so much harder. I can just tell you right now, only because we're starting so high. And again, I'm definitely way off there. Let's see. See if I can get a steady hand going here. If not, you can just have fun watching me do this. Okay, that's getting closer. And now we just want to curve off. Wow, this probably is the best one I've drawn. Let me not say that I still haven't finished it. There we go, close enough. And so we have now 3 different, and we're told to, let's not forget, write their equation on each of them. So this would have been y is equal to 10 divided by x. All right. And this one I should have written in green. It's going to be very difficult to fit this in there. But let's just say y is equal to 6 divided by x. It would have been nice to have written in green. Okay, and you can barely see it. I do apologize. I have to write sideways. Using a pen tab, it's just not the same as using a paper and pencil. The last one, or really what was the first one, y is equal to 4 divided by x. So we've labeled them. We have followed the rules, which you should follow. Follow the instructions, rather. So we've labeled them. So we have 3. Now, what are the constants of variation for these functions? Well, we can see that's 4, it's 6, and it's 10. All right. So for each of these, so for a, it's 4, for B it's 6, and for C is 10. Okay. And how are the constants of variation related to the distances of the curves from the origin? That's an interesting question. Now, where's the origin? We need to find the origin, and we have here, the origin is here. So what are we noticing? Let's just read again. How are the constants of variation related to the distances of the curves from the origin? Well, as the constant variation gets higher, or it gets farther, or it's larger, it gets farther, right? So the first one, it's only out to here, but the second one, it's out to here. So imagine if this is coming closer, this is actually curving upward. It's just going to go so far. So it as you approach the y-axis, as you approach 0, let's just say, it's just going much higher. But just let's take from the origin, we could see that these distances are further away. So the higher this number, the further we are from the origin. At least let's just say with this particular number 1. Okay, that being 1 being the x value. Okay, now so we've sat down, we took some time, and we understand now how the constant uh, uh, determines the position and the shape of the curve. That's what we looked at. We looked at the curve. We looked at the shape. One's kind of higher coming down. They all sort of start bottoming out towards the bottom. Um, but you can see where the higher you go, you sort of have to come down longer. It's almost, I want to say almost like a steeper drop there. Um, so, and we can see that the distance, the position, is farther as that constant gets larger or higher.